here's what I need you to understand. We already took a look at measures of spread, right? We started looking at measures of spread and central tendency. And what we were looking at was mean, median, and mode. We looked at that, we talked about it, we did some math around it. We said that the mean was the average, the median was the middle, and the mode was the end of, then the mode was the most copied number in a set. Now, there is a problem. There are other ways to look at a set of data. Now, it's useful to spread out that data, and how we could do that is using a thing called measures of spread. Now, I'm going to go over, I think it's three ways to measure the spread of information, with two minor ones near the end. Okay, now consider these 21 test scores out of 100, right? So there's our test scores, right? And here's what we're going to do. The first thing that we have to do is we're going to rearrange all this information into a line. Now, you remember, we always have to take our information, organize them from lowest to highest. But what we're going to do is we're going to actually take a moment and split this into quartiles. Quartiles means 25% of all of the data is within these specific boxes or ranges, right? And from there, we can go and make a thing called a box and whisker plot. Now, let me show you how this works. If I looked at this set of data here, the median would be based on the fact that we have 21, a set of 21 things here. Uh-oh, where'd you go? Oh boy, oh no, it disappeared. There's 21 pieces of data in this set, right? And here's the thing. We need to find the middle quartile. The middle quartile is in the center. The middle quartile just happens to be the median. Now, if there's 21 data points in this set, right, we'd have to take 21 divided by 2, and that's 10.5. We round up, that's 11. So we'd have to count from 48 all the way up to the 11th spot in that list, and the middle term, which just happens to be 69, ends up being our median. And in our median for this set of test scores, the median is what we call interquartile range number 2. In quartile number 2 is 69%. Now, the fact that our list is split into 2, we can take this list. So all we're doing now for our first quartile is we're splitting up our last half of data, which isn't touched, and then what we're looking for is the middle number in this set. Now, because we took out 69, there are only 10 spots here. So we would take 10, divide by 2, and go to the 5th spot. But because this is an even set, we have to basically take those 2 middle numbers that are in the center, divide by 2, and that would be our quartile for the first half of the chart. And if you really think about it, it's nothing more than the median of the first half of the chart. Now, for the second half of the chart, the second half of the list, what you're going to do is you're going to bust it up. You're going to have 10 spots. You're going to basically go and do exactly the same thing that we did for the first half. And we call the middle term here our interquartile, our third quartile, right? Now, our third quartile is going to be 79.5 because we have to average 80 and 79 to get what we're looking for. Now, that is what we do with quartiles. Interquartile range 1 is the median of the lower half of our list. Interquartile range number 3 is the median of the top half of our list. So you could literally tell me what those are. I could ask you to calculate that. And that's what you're going to do today. Now, for the range is different, right? The range is the difference between the least and greatest values in a data set. Now, when we're talking about the interquartile range, right? We're talking about the difference between quartile 1 and quartile 3. So we're literally just going to do this. We're going to take the range, we're going to take the interquartile range to be Q1, Q3 minus Q1, which is this, and that's our answer. Bob's your uncle, right? Now, when we're talking about the range of a set of data, we're talking about everything in the set. And we're talking about subtracting the biggest from the smallest, which is really 90 minus 48. Okay. And 90 minus 48 is going to give us some information. Now, for some reason, my 48 is missing. So 90 minus 48 gives us 42. Now, from here, we can actually use all this information that we were looking at. We call this thing on our right here a box and whisker plot. Basically, what the box and whisker plot basically shows us, it shows us where 50% of all the information is. You basically have a number line, and basically along the number line, you're just showing me a box where the first spot is, the second spot is, sorry, the first spot, the interquartile range 1 is, sorry, the Q1 range, the Q3 range, and then the last. Now, you end up putting a box around exactly where those quartile ranges are. And you notice that this middle spot here, this middle spot is literally our interquartile. That, sorry, is not our interquartile, it's interquartile range 2, which is nothing more than your median that we studied before. Now, variance and standard deviation, they are two important things, right? When you hear about the standard deviation or the variance is the square of the difference from the mean to every point. That's all it is, okay? And if you look at variance, it's literally x1 minus the mean, x2 minus the mean, x3 minus the mean. So basically all of these x's are in our set, and all we're doing is subtracting. Now, because this thing is so regulated, I would suggest that when you're doing these calculations, you take the time and learn how to use Excel or Google Sheets, okay? To calculate the mean, what you would use is the function called equals average of a whole bunch of cells. And I can show you how to do that later after the lesson. But for now, you're going to go and do these by hand. So if I was looking at our original set, remember, you have your variance, which is your data point minus your middle, your data point minus your middle, your data point minus your middle. Not your median, but your average. So you could calculate the average by hand for this set here, okay? And once you've got your basic set, your basic mean, you can use that to calculate the variance by subtracting each of the data points from the mean. And then you end up with something like this, which is something like this, which is this, which is 2,726.7, which gives us a variance. Now, a variance doesn't really mean much. All it does is it kind of gives us an idea of how spread out the information is. But something that is even better than the variance is this thing called the standard deviation. Now, the standard deviation is nothing more than the square root of the variance. So this variance thing that you calculate, all you got to do is square root it. And it literally tells you how far from the center you have to go out to get exactly 50%, 25% above, and 25% down, i.e. that box and whisker plot of 50% of our data. It literally finds the length from here to here mathematically. Now, one standard deviation is within one quartile range, and it literally can do this for you instead of having to draw that box and whisker plot. So remember, your standard deviation, SD, is always equal to the square root of this thing, the variance that we talked about. All right, and now with the variance, we're going to go and talk about something new. So here's this dude. His name's Ferd. He works part-time selling synthetic hairballs for ceramic cats. He recorded a number of hairballs sold at nursing homes each month for the last 12 months. So he has all this information, and what we normally have to do, if we have to find the median, the first quartile, third quartile, and interquartile range, and then display them in a whisker plot, the first thing we have to do is we have to take our time and ensure that our information is listed. Now, basically this number of points that is here is basically basically an even number. So when we go and figure out our number of points, we're going to end up finding our median for this thing being in the center, right? And the only way that you can get the center is by taking 25 and 39 and then averaging them. Okay, 25 and 39, when you average them, gives you 32, which is your second quartile, which is also your median for your set, right? So now that we have 32, 32 is not in this list. So that means 25 down to 6 is in the first half, and 39 to 46 is in the second half. So what we're going to do in order to find our points is we just have to find the middle point of our next set, which is also even. So we take 13 and 17, divide by 2, we get our middle point of 15. And we do the same again for this half. So essentially what we've done is figured out 3 medians for 3 different sets. One for the big set, and then one for the lower half, one for the upper half. Remember, the upper half is interquartile range number 3. The middle one is called the interquartile range, the quartile 2, and then the last one at the beginning is Q1, we call it. Now the interquartile range, here's what you have to do. Interquartile range is Q3 minus Q1. So it tells us the spread between Q3 and Q1, the spread between Q3 and Q1. And in this case, it's 28.5. When we want the range, all we're going to do is to subtract the big from the small. And we end up with 40 in this case. Now, in order to draw the box and whisker plots, we have all these 3 things. We have to set up a basic number line. Okay, and now our basic number line has all of these numbers in it, right? 30, 40, it's going to have 45 in there. It's going to have to have 43.5 in there. And then what we do is we literally just draw our box over it. So for Q2 and Q3 and our last value and our first value, we set up where they are on our chart. Then all we have to do is draw the inner box. Okay, and then we draw the line for our center, the line for where Q2 is. And Q2 is here, so guess what? There's our half. Then what we do, boom, boom. And there's the end of our box and whisker plots. And we're done. That's it. It's not that difficult. Okay, so let's move on to the last video lesson. So now this is the next one. This problem here is talking about is talking about range and mean, but then we're also going to use this to go and calculate the standard deviation. And as you can see, we have a table here of information here. Now, wouldn't it be nice to be able to use a computer to do most of this? If you want to know how to do it with a computer, let me know and I'll show you. If not, then you'll have to do this by hand. So in order to calculate this information, right, we literally have to take the information, we have to order it. So you order it, right? You figure out your range. If we needed to go and find the mean, we would have had to have ordered it. But we just find the largest from the smallest. You end up finding our answer is 61. So now when we find the mean, all we have to do is we have to add all our information, divide by 12, and we end up with 75. So that is what our mean is. So here is how we calculate the variance using a table of information. You write down all the numbers, and it doesn't matter how you organize them. Just take the numbers and throw them in this chart. Then what you do is you take 61 minus the mean, which is 75, gives you negative 14. And you do that over and over again ad nauseum. And you end up with these numbers that are on the right here. Now, remember what we had to do with our variance. With our variance, what we did was we had to go and square all those differences and then add them up. So let's go and do that. So you square all the variances and you end up with this. Everything is positive. If you end up with a negative mean, a negative squared, you got a problem. So you add up all of these numbers, and then here's what you do. There's your answer. So that answer helps us find the variance. So here's how you find the variance. The variance is just whatever the number is divided by the number of points that are in this set, which means that the variance for this problem is 84.75. Now, the standard deviation, we said, was the square root of the variance, which is equal to the square root of 84.75, which means that our standard deviation is 9.2. You are responsible for being able to do these types of problems. You need to be able to calculate the variance. You need to be able to calculate the first quartile, the second quartile, and third quartile. You also need to be able to calculate the mean, median, and mode, right? Now, let's take a look at this last problem. A company needs bolts for heavy machinery. The company must choose between two manufacturers. The mean is 72. The standard deviation is 2. All right. So, and for Qualitech, its mean length is 72, and its standard deviation is 0.1. Which manufacturer do you think you should choose? Well, let me give you the reason. Both of them have a mean of 72, but one of the companies produces a better product. A better product in the sense that the product is built in such a way that the difference between one object and the other is very small. This one is very bad, but this one, oh yes, is very good. It's very good because the standard deviation is small. It's very, very small in this case. All right. So that's basically it, right? So for this first one, for the bad manufacturer, its basic variances go from 70 to 74. You could literally have differences of lengths between 70 and 74, while this one here gives you more uniform solutions where you have somewhere between 71.9, which is a subtraction from the mean, and 72.1, which is an addition to the mean. And that is why those two things are good. Now, can the range of a data set be 0? Would this indicate what would this indicate about the interquartile range? Here it is. Ready? Imagine I had a set of information, 10, 10, 10, 10, 10, right? Here's the range. 10 minus 0 is 10 minus 10 is 0. What does that tell me about the mean? The mean is 10, the variance is 0, and the standard deviation is 0. Guess what else the interquartile range is? It's 0. And we are done. Okay? Now, your homework is, it's online. I've given you page 145 from a textbook that I used to use. I will put up the solutions a little bit later. Your job is to work on these problems. 5B, 6B, 7B, and 8. 2A, 3, and 4, you're going to calculate the range. And for the last bit, you're going to go and calculate quartiles. After I'm done teaching